from ellipse. All right, so this is an ellipse. So an ellipse, so unlike a circle where a circle is basically the exact same all the way around, that's why it's a circle, an ellipse can be either horizontal or vertical as its major axis. So it can be pulled one direction or the other direction. The formulas for them are basically the same with slight differences in them. So as you can see on the screen, the first formula, the horizontal major axis, it's x minus h squared over a squared plus y minus k squared over b squared. The only difference between that one and the vertical axis is the a and the b is switched. A is always the bigger number. So that's how you're going to tell which one it is. So if a is under the x, my horizontal major axis is the x-axis. Or major axis is the x-axis. If the a is under the y, the bigger number is under the y, then the y is my major axis, and that's why it's vertical. When you go down to the bottom to figure the pieces of it out, the center is the same. It's just h and k. Your vertices, which is the endpoints of the ellipse, if it's on the horizontal one, you're adding the a to the h. If it's on the vertical one, you're adding the a to the k. The co-vertices, the opposite ones, the minor ones, you're going to do the opposite. You're going to add the b to the k for the horizontal one and the b to the h for the vertical one. So you're always adding the letter to the variable that it's above. So the a is being added to the x, the b is being added to the y. And then for the vertical axis is the opposite. The b is being added to the x, and the a is being added to the y. The next piece of information that we have from that is the foci. Now, the foci are actually the values inside of the ellipse. These are points where if I was to send a sunbeams anywhere or rays to the ellipse, and it was to bounce off the side of the ellipse, it would all focus right back on that foci. The easiest way to think about this is actually your eyeball. If you are a person that has to wear glasses, it's because your foci is not at the back of your eye in the retina. So as if your curve isn't perfect, it's not focusing correctly. So it's not hitting that, the foci is not in the right spot. So you wear glasses or you wear contacts to change that curve, to change where the focus is, and have it focus in the correct spot so everything is in focus. That's what that foci is. So we have to either add or subtract c to the h or the k, depending on the direction we're going to go. And we find c by doing a squared minus b squared. It's kind of like the Pythagorean theorem, except it's subtraction instead of addition. So make sure you have those formulas written down, because we're going to use them for the next about 7 problems. The next 7 ones are all ellipse problems. Give you another minute or so to write it down and go on to the questions. All right. So first question. The first thing you have to look at is it a y major axis or an x major axis? And that we tell by where the bigger number is. So since my y has got the 36, that's the bigger one. So this is going to be the vertical major axis. So when we're graphing an ellipse, let's see what we actually need to do this one. Center. All right, so to graph it on this one, you need your center, and then you need your vertices, and then your co-vertices. So my center for this one is 1, -2. Now, my vertices, I've got to take that 9 and divide it by 2, or square root it. Gives me a 3, and then 36 gives me a 6. So this is my B, and that's my A. So since it's on the vertical, I'm adding the a to the y. I'm going to add and subtract it from. So my vertices is going to be 1, -8, and 1, 4. So I subtracted 6 from the -2, and I added 6 to the -2. My co-vertices, now I'm going to add or subtract the 3 from the x. So that becomes -2, -2, and 4, -2. Are my co-vertices. When we graph this, you only need one of each of those. So my center is at 1, -2. My vertex is at 1, -8. And my co-vertex is at 4, -2. Any questions where I got those pieces from? The next one's the same thing, but notice they don't give me the information. So I've kind of got to come up with my problem a little bit here. So I've got 9x squared plus 16y squared equals 144. Now, notice that I don't want a numbers in front of my x and my y from my formula. So I've somehow got to get rid of those. So what we're going to do is we're going to divide. So the first thing I'm going to do is divide everything by 9. So when I divide everything by 9, I get x squared plus 16y squared over 9 equals 16. Now I'm going to divide everything by 16. So I get x squared over 16 plus y squared over 9 equals 1. Now this formula is in the correct format. So I can come up with my vertex, my vertices, my center, and my co-vertices. So my center for this one is 0, 0, because there's nothing added to the top of either one. My vertices, since the x has the bigger number, I'm going to add or subtract 4 from the x. So it's 4, 0, and -4, 0. And then my co-vertices, I'm adding or subtracting 3 from the y. So it's 0, 3, and 0, -3. So when I graph it, my center is at 0, 0. My vertex is at 4, 0, and then 3, 0. So 0, 3. So your vertices, so the reason why I'm adding subtracting 4 is because it's the square root of 16. Because remember, the formula for this part right there is a squared, and that's b squared. And I want a and b. So that's where so a is 4, and b is 3. So I'm adding and subtracting 4. And since it's underneath the 16 or the x, I'm adding and subtracting it from the x for the vertices, because that's the bigger one. My co-vertices is my smaller one. So I'm adding and subtracting the 3. And since it's under the y, I'm doing it to the y value. So that's how I get the co-vertices, 0, 3, and 0, -3. We're going to do more of those in a minute. Add a little more complicated here, probably. All right. So now this one. It's actually the same thing in the last one. The difference is we got more stuff and I have to do more work with it. So the first thing I'm going to do is I'm going to put the x's together. So I have x squared plus 10x. And then I have 9y squared plus 36y. And I'm going to move the 52 over to the other side. Now I'm going to take out that 9. So I have y squared plus 4y. Because again, my goal is to get something that I can find perfect squares for. So the first one, I've got 10. So I'm going to add it. I'm going to do 10 divided by 2 is 5. 5 squared is 25. So this becomes x squared plus 10x plus 25. And now my 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 to that side. Now, what did I add on the left side? I have to add to the right side. So I added 25. I also added 36 because that 4 times the 9 is that 36. So this problem becomes x plus 5 squared plus 9 y plus 2 squared equals 61, 9. Now, another way, an easier way to look at what I did in the last problem when I got the 144, or I got the 1, is this problem at the end always has to equal 1. So we're going to take that 9, and I'm going to divide the whole problem by that 9. So I get x plus 5 squared over 9 plus y plus 2 squared over 1 equals 1. So that's the equation I'm going to graph. Now, from there, I need to find my center, my vertices, and my co-vertices. So my center is -5, -2. My vertices, my A is 3, and my B is 1. So I'm going to add or subtract 3 from the x. So I get -8, -2, and -2, -2. My co-vertices, I'm adding or subtracting 1 from the y. So I get -5, -3, and -5, -1. And then we graph it. So I get -5, -2, -2, -2, and -5, -1. So you see the last problem in this one, basically the same step to graph it, just a little more work to get the equation in the correct format to be able to graph it. The nice thing is when you're going through and doing these topics, the first topic you're going to have to do is using the equation to find the center of the vertices and the co-vertices. So you'll get that down really well. And then when you go in and do the other problems and you have to find the equations, you're only basically worrying about solving the equation for it, because the other parts you already know how to do. So really, the algebra here to get the equation is the hardest part of this problem. So it's not vertical and covertical, it's vertices. So your vertices. All right, let's try this a little bit of a different way. I'm gonna actually look at, and we're gonna look at the graph. Let's explain this one. So my center right here. So my center right there goes at -5, -2. Okay. So when I'm looking at my A and my B, so my A is +3 and -3, because A squared was 9, so A is ±3. And that's how I get my -2, -2, and -8, -2. Does that part make sense? Okay. My covertices are the same thing. They're just the opposite direction. So B squared was 1, so B in this case is 1. So it's 1 down, so -1, and +1. That's how I got the -5, -1, and -5, -3. And that's my center. All right, so that's the vertices and covertices. No, you can't write them after drawing them, because you need them to draw them. I was just explaining to you what they are. So like the thing you're doing is you actually have to find them from the problem, because you need them to actually grapple. And I'm doing exactly what I just did in the drawing algebraically. I'm adding 3 to the x's, and I'm subtracting 3 from the x, because A is 3. I'm adding 1 to the y, and I'm subtracting 1 from the y to find the covertices. All right. The next problems don't have you graph them anymore, but we have to come up with a bunch of information from them. So we're going to get more of the how to find the vertices and all that other stuff to it, which would be nice. So they gave me the equation. They want my center, my vertices, and my foci. So this one's adding in that foci part. So my center in this case is 3 and -5, because it's the opposite of the numbers on top. Now, my A is 10 and my B is 8, because it's the square root of the 100 and the 84. And A is always going to be the bigger one. Now, to find my vertices, I'm adding and subtracting 10 from my x. So it's h plus or minus a k. That's the formula for it. So 3 plus 10 is 13, -5. 3 minus 10 is -7, -5. So there's my vertices. Now to find my foci, I need C. So C squared equals A squared minus B squared. So this is 100 minus 64. So C squared in this case equals 36. So C equals plus or minus 6. So my foci, we're going to do the exact same thing. We're adding and subtracting from the x, the same way that we did for the vertices. So, but this time, it's h plus or minus c. Okay. So I've got 3 plus 6, which is 9, negative 5, and 3 minus 6, which is negative 3, negative 5. So those are my foci. So your foci are in the same line as your vertices. If you were graphing, they're on the longest side. So center is 3, negative 5. And signs are very important in this. So if you mess up your signs, you're probably going to get all the answers wrong. So be very careful when you're doing your signs for these. And it doesn't matter the order. You could have put the negative 7, negative 5 first and 13, negative 5 second. That doesn't matter. But your signs do. Any questions with the foci in this case? Because that's really the only new thing in this problem. All right. Yes.
Can you explain once again what the foci actually is?
So, let's see if I can. Actually, where did it? I need a picture. Hold on. All right. Actually, you know what? I want the bigger one. Okay. All right. So here's the foci. I'm totally making, because I'm not calculating this one. So we're going to assume that's the foci right there. Okay. So what the foci does is any line that comes in. So say I have a line that comes in here and hits that, it would bounce directly to that foci. So if I had another one that comes here, it would bounce to that foci. So no matter where the line's coming in, it's going to bounce directly to that foci. That's what the foci does. It basically is focusing the light that would hit the actual edge of the ellipse. It works, a parabola has a foci, which most times when you guys graph parabolas, you weren't thinking about that. But a parabola has a foci, ellipses have a foci, circles have a foci too. They're actually at the center of the circle because it's equidistant all the way around. And a hyperbola has a foci too. But that's in essence what it means. It means as things come in, they would bounce directly to that foci. Does that answer your question?
Absolutely, thank you.
No problem. So in an ellipse, there's a foci on both sides. That's why we're finding 2 for the foci. There's one on either side of the ellipse. And say in a parabola, there'd only be 1 because everything's coming down to that 1 point. And a hyperbola, there's going to be 2, 1 on either side of the hyperbola. All right. No problem. All right, so now this question is giving me this whole problem, and all it wants is the foci. The reason why they can just ask for the foci is you basically have to do everything else to find it. So we have to do a bunch of work to find one thing. So first thing we have to do is clean up my equation to get into the correct form. So I have 25x squared plus 100x plus 9y squared, and that's it, equals 125. So I'm going to take out the 25, and get x squared plus 4x. I'm going to take out the 9. Now, I have the 25. So the first thing I have to do is I have to figure out this 4x over here. So in this case, I have a 4x. So 4 divided by 2 is 2. The 2 squared is 4. So I have 25 x squared plus 4x plus 4 plus 9y squared equals the 125. And I'm going to add 100 to that. So I've got 25 x plus 2 squared plus 9y squared equals 225. Now I'm going to divide the whole problem by 225. So my equation is x plus 2 squared over 9 plus y squared over 25 equals 1. So my center is -2, 0. A is 5, and B is 3. Remember, the A is always the bigger of the two, not necessarily the one under the X, but it's always the bigger of the two. So A in this case is 5, and B is 3. So I need to find C. So C squared equals 5 squared, so 25 minus 9, 16. So C equals plus or minus 4. So I take my center, and I do plus or minus 4. The key is which one are you doing it to, the X or the Y? And you're going to do it to wherever the A was. So in this case, since my A is under the Y, I'm doing it to the Y values. So my foci is H, and then it's K plus or minus C. So I've got -2 plus 4, and -2 minus 4. How many 2 foci for this one? So -4, and -2, -4. So a lot of work for one answer, but you basically have to find everything to figure out that one answer. Okay. 2 more. Yep. All right. So the next couple of problems are going to give you points of information, and they want you to find the equation from it, kind of like what we do with the circle. So depending on what piece of information they gave us, depends on what information I know. So the first thing they gave me in this case was my center. So my center is 4, -3. So that means H is -4. Oh, sorry. H is 4, and K is -3. Now, the other piece of information I need to know is A and B. So they gave you the minor axis length. So now when we're looking at a, actually, they probably have a nice picture. And they don't. We can kind of use that. So the minor axis is going to be that length right there. So it's the line that goes directly through the center on the shortest length from the sides. So they're telling me that that minor axis is 6. So now remember, when we were doing the value, we were adding and subtracting from the center. that number. So if I was going to go from the center and add or subtract, I'm not adding or subtracting 6, I'm adding and subtracting 3. So B, in this case, is 3. Does that part make sense before I go on? If they gave me my minor or major axis length, I would have done the opposite one. So, all right, so they tell me the minor axis. So the minor axis is that short direction. So I'm in the center here. And from that point to that point, all the way across, is 6. So that's going to be the +3, and that's going to be the -3. Because if I go from the center up 3, both directions, I'm going to get to 6, correct? So you got to remember what we're doing when we're adding and subtracting. We're doing the same number to both. So that's where that 6 comes into play. Same thing is true for the major axis. We would do the same thing, except it would be just a different number in that case. And it would be the long side, but you still basically just cut it in half to find your A or your B. So in this case, they gave me the minor axis was 6, so that means my B is 3. The next piece of information they gave me is they gave me one of my vertexes. So my vertex is at -4, -3. My center is at 4, -3. So from here to here, from -4 to 4, is I would subtract 8. So go from the center to one side. So to get to the other side, I would add 8. So that means my A is 8. Because it's what's changed in this. Now, they had given me my major axis, they would have had to give me one of my co-vertices here to be able to find my B. So they're always going to give you either the minor axis and a vertex, or a major axis and a co-vertex to be able to find out the A and the B. And you basically are going to do that same thing. You're just going to find the distance from the center to that point. Now that I know my H, my K, my A, and my B, I can write my equation. So it's x minus 4 squared over, and it's y plus 3 squared over equals 1. Now, the next part of the question is, where does the A go and where does the B go? You can tell that based on which value changed on the one they gave you. So since they gave me my vertex has the x changing. So that means my A is going to go over to my x. So that's the 64. And my B is in the other spot. So if they're giving you the vertex, that x, whatever one changes there is where my A goes. If they gave me my co-vertices, it'd be the opposite. That'd be where the B is going to go. So
this might be an odd question, but why does it have to equal 1?
It's just the rule. It's because they have the division in there, and the division basically makes it equal 1. You don't have to have it equal 1, but that's the only way to get your A and your B. So if you think about a circle equals the radius, right? In an ellipse, we basically have 2 different radiuses. So the only way to be able to find out which ones or what they are is to actually make it equal to 1 and divide everything by it.
So this is almost like proportions, giving us an exact proportion, and you set it equal to 1, obviously rather than 0, because that's each side of that equation, where the x side and the y side of that equation, those are like proportions.
Basically, yeah, they're going to be inverse, or they're going to be because they'll be the negative version of it. But yeah, so like the x minus 4 squared over 64 equals the negative y plus 3 squared over 9. So yeah, it would be the opposite. And that's where you get the opposite direction from it. All right, let's check it. Okay, so got one more of these. Same concept, just different information they're going to give me. All right. So this one. So again, we still need, no matter what, when we're doing these problems, I need H, I need K, I need A, and I need B. So no matter what happens, those are the three things I need. So this one, they give me my major axis length. My major axis length is 8. So that means that's the A value. And half of it's the A value. So that means my A is 4. The next thing they gave me is my foci. So I have 7, 0, and 1, 0. So those are my foci. Now, right in the middle, so remember, my foci, my vertices, and everything all come from my center value. So I can use my foci to find the center. Once I find my center, I have my H or my K. So what's halfway between the 1 and the 7? So 1 plus 7 is 8, so that'd be a 4. So that is my center. So H is 4, and K is 0. Because they're going to be equidistant from that point. Now your foci doesn't give you B, but it does give you C. So here I'm doing -3 and +3. So C is plus or minus 3. So that means, so I have C squared equals A squared minus B squared. So C is 9, A is 16. So I can minus, and I get -7 equals -B squared. So 7 equals B squared. So B is the square root of 7. So because we had the foci, they gave me the C value, so I was able to use that to find, with the other information I had, to be able to find B. Now, where's the A going? Is the A going to go under the X or the Y? And the way you can figure that out is which value changed in the foci. The value that changed was my X. So therefore, my bigger number, in this case, it's going to be 16, is under my X value, and my Y value will be 7. So with a little bits of information, you can work your way through to find the full equation. And people ask all the time, it's like, when do we ever going to use this? If you do any kind of physics work, you use this stuff all the time. Most of your stuff in science, especially your physics stuff, uses these types of equations and these types of formulas. And a lot of times, they're more going to be giving you information because you're going to find information about the experiment, and you have to create the model from it to be able to figure out other stuff. And when you create the model, you typically are creating either ellipses, hyperbolas, parabolas, and stuff like that to be able to figure out the extra information. All right. That is the end of ellipses. So I'm going to stop this recording.